Hi everyone, welcome back to my channel. Uh, Today we are going to start with a introduction to SD-WAN, wherein we will start with the WAN connection. What are the different WAN connections? Starting with the lease line, MPLS, the tunnel concept of the GRE and IPsec. Then we'll proceed with the traditional enterprise environment, how the environment look like in today's world, and then we'll proceed with the legacy and the SD-WAN concept, where we'll start with the introduction of SD-WAN. We'll explain different controllers and the devices on it. So let's start with that. And so you can see now we have, means I've created this small topology where where we have the branch routers. So we have so this concept, starting with this concept, we have branch 1, branch 2, and the data center. So here, let's suppose, just give me a minute. Okay, now let's see this topology diagram where we have this branch 1, branch 2, and the data center. So this, let's suppose this branch 1 is in Delhi, this branch 2 is in Mumbai, and this data center is in Pune. Okay, so with this traditional WAN connectivity, starting with the lease line. Okay, so this lease line is provided by the service provider. Okay, and this internet cloud, here we have a service provider. Okay, this service provider will provide a lease line from this branch 1 to data center, and this same data center to a different branch. This is a costly concept wherein all the routing is done by the service provider. So here we have one uh, router. So here we have one router, the other router is in the data center, and the routing between these two routers is done by the service provider. Okay, so the routes from this branch 1 goes to the data center through all this routing is done by the service provider. Okay, so now the second one is MPLS. So this MPLS is uh, this MPLS is multi-protocol label switching, wherein we'll use the concept of labels. We will use LDP, which is label distribution protocol. There is a routing protocol run between these two routers. Routing protocol, whether it's OSPF or BGP. So the routes will move from this one, from branch 1 to the service provider router, and the service provider router will pass on the routes the uh, to the data center, and this is how the communication will happen. Okay, so if branch 1 want to access any application which is hosted within a server in the data center, so it will the service provider will uh, provide the routing, provide the traffic flow from the branch 1 to the data center, and then the branch will be able to access the file which is stored in the server in data center. Okay, so this MPLS concept, after this MPLS concept, here comes internet con internet internet link. So this internet link, so let me clear this one. So on this internet link, So here we have this internet link. Here we have different routers within this internet link. Okay, so the routing happen here, like in there's a router here. Okay, it will form a routing protocol between the routers. So here it is difficult to run a routing protocol because according to uh, IGP Internet Gateway Protocol, the router should be directly connected to share the route between the two routers. Okay, but here we have different ops within the internet. Okay, so because it's a public cloud, you can say. Okay, and there is no security on it, no security on public cloud security. Okay, so to run the routing and to pass on the traffic between branch 1 to data center, we'll use a concept of tunnel. So tunnel is a logical link which is formed between branch 1 and data center. Same goes for the data center to branch 2, and then between branch 1 and branch 2. Okay, so this logical link which is this logical link which is formed is called overlay overlay network. Okay, and this overlay network is run ab above internet link which is called underlay network. So the concept here is this logical link is overlay and this internet link is underlay. Okay, so this tunnel is basically a GRE GRE tunnel. Okay, so so the packet which goes from this branch to this data center. So this packet is means this packet is not means secure over the public internet because we have an internet connection which is a public internet wherein there is a traffic of multiple customers and all. And to secure the traffic from one location to another, to pass on the traffic from one location to another over a internet link, we'll have to encrypt this packet. Okay, so this packet have to be encrypted, and to encrypt the packet we use a concept of IPsec. So there is a IPsec. We use IP security to encrypt the traffic over a tunnel. So yeah, we can also call it as a IPsec tunnel. This IPsec tunnel is formed between one location to another. Okay, to secure the communication the branch and the data center. Okay, so this is you can say this is history of the WAN connectivity. Okay, and we're gonna use the same links like MPLS internet and uh, the 4G connectivity or the 5G connectivity in SD-WAN also, and we call that as a transport links. Okay, I'll let you know on that part later on after we'll complete the concept of the traditional network. Okay, so um, so now guys we have this new topology wherein we have multiple branches. Okay, and the branches are connected to the data center through the transport link which is MPLS and the internet. So here you can see that branch 1 is connected to both MPLS and internet. Branch 2 is only connected to MPLS link. Branch 3 is connected to MPLS internet, and branch 4 is only connected to internet link. So these branches will use the MPLS and internet connection to reach the data center. Okay, so in the enterprise environment, we have okay, so in the enterprise environment, we have different servers in the data center. Okay, so like in we have a file server. So this is so this one is this one is one of the server. So it can be a file server, or it can be an application server. Okay, so on the data center, we will have for security, we'll use a firewall. Okay, and to access the file server or the application server, the branch routers, the branch um, for each branch we have these routers here. Okay, so okay, these routers. Okay, so the branches will use and the servers will access the applications or the files in the which is stored in the server in data center. Okay, so MPLS and internet link is providing the connectivity from branches to data center. So MPLS will take uh, so this MPLS will take routes from the branches and advertise it to data center. Okay, for internet will use GRE or IPsec tunnel and run a protocol routing protocol uh, in it and advertise the routes to data center. Okay, this is how the connectivity will work in the enterprise environment for a traditional enterprise environment. So these MPLS and the internet links are called the transport links. Okay, so these every branch want to use the service stored in data center um, through these MPLS and internet links. Okay, and generally what happen in traditional enterprise network. So this data center, there's a hub and spoke topology. So this data center will work as hub. Okay, and the branch routers will okay, so these branch routers will act as spokes. Okay, so the traffic will flow from uh, so the traffic generally flows from the hub to the data center, from the hub to the spokes. Okay, from this hub to the spokes and hub to the spokes, hub to the spokes. Okay, so there will not be any communication between branches. So no communication between branches directly. So if branch 1 wants to reach to branch 2, it will have to reach reach it via hub connection. Okay, so the hub and spoke topology normally used in a traditional enterprise network. Okay, so okay, let me clear this one. Okay, so some enterprise network do want a communication between branch sites also. Okay, and for security, for securing the traffic, it should be moved through a it should be moved through a firewall. Okay, and which is stored in data center and then into internet. So the traffic is more like in the from branch 1 the traffic will go via MPLS, okay, and then goes to data center, okay, and then from data center it moves to firewall and then to internet, okay. And uh, and there is nowadays nowadays the to manage a data center is very costly, okay. What uh, what the enterprise environment is moving to a concept of cloud, okay. So cloud wherein will means um, the administrator will store the applications within cloud like Office 365, okay, uh, drop, okay, so Office 365, uh, Dropbox, okay, and its application as a server, okay. So these are the means, so if someone within a branch wants to access to any application, it will go from branch 1, okay, branch 1 goes to data center, and then it will go to firewall for security, again then move to internet and then do access the application which is stored in a cloud, okay. So this is how the traditional network will work, enterprise network will work, okay. We clear this one. Okay, so the other concept of this traditional network is the transport link is MPLS and the internet. So basically, uh, this MPLS link is acting as a uh, primary link. Okay, and this one is act as backup, or you can as a secondary link. Okay, so all traffic will move via the MPLS link. Okay, and in case there is any issue with this MPLS connectivity, all traffic will shift from MPLS to internet, okay. So like in wise, if there is high latency on this link towards the data center, okay, some packet drops on this MPLS link, or some jitters, okay. So then we have to move the traffic from MPLS to internet link, and the process of doing moving the traffic is a manual process. So we have should be running a routing protocol, and then we have to uh, shut down the neighborship to this MPLS, and then uh, so that the traffic will uh, move from the MPLS to the internet link. Okay. Um, so so this is a traditional enterprise network, okay, and so there are basically some issues with this enterprise network, okay. So I'll explain the issues. So I'll explain the issues in the enterprise network, and I'll let you know how these issues can be resolved in SD-WAN, okay, the technology of SD-WAN, okay. So the issues as in, how do we monitor the performance of an application? So for to manage the performance of an application, we need an optimal path to access the application. So within a cloud, we have an application running like Office 365. Okay, so we want to access this application. So the traditional MPLS environment says we have to move from branch 1 to MPLS, then to data center, then to firewall, and then to internet, and then to cloud. Okay, but we need an optimal path, and the optimal path is for branch 1. we have a direct connectivity with the internet link. Okay, so we can move the traffic from the internet and then move to cloud. So this is one of the optimal path. Okay, um, to this is one of the problem. And in SD-WAN, the concept is basically we have uh, we have a centralized system. We have a centralized system which monitors both these MPLS and the internet link. So both transport um, links will be monitored. Okay, and if there is some issue with any of the link, so if there is um, high latency, packet drops, or jitters on any of these links, the traffic will move from one link to another link, so that the performance of the application will not be degraded. Okay, so the application, the users which are trying to access the applications, they will be able to access the application without any issue. Okay, so this is one of the problem with the enterprise, and this can be fixed to the SD-WAN environment, means where we will use a concept of vSmart. Okay, so this vSmart will uh, monitor the transport links, and if there is any issue with any of the link, it will move the traffic to from one link to another link, so that the performance of the application will not be degraded. Okay, so let's move to the second point. Okay, so the second point is cloud connectivity. So in cloud connectivity, managing this, I told you earlier that managing this data center is very costly. Okay, and to host the application within data center is costly. Now the enterprise is looking for a cheap solution. For a cheap solution, they will host the applications within cloud. Okay, so the clouds we have AWS, Azure, or GCP. Okay, so the enterprise will use any of the providers of the cloud and will use their environment to store the applications. So like in for AWS, we have different data centers in multiple locations. Okay, so to host an application, the enterprise will look for a data center which is near to their location, so that there will be um, less latency. They will find an optimal path for an application which is near to their sites. Okay, so they will look for a data center which is near. Okay, and which have less latency, so there will not be any problem of latency on it. Okay, and so this data center concept in AWS is called availability zones. Okay, okay, so that's in a whole new topic for cloud. Okay, and for so this is the second one. So the third one here is security. Okay, for security, in traditional environment we have a firewall. We need a firewall. Okay, and this firewall uh, will be in data center. uh, its firewall will be in data center um, to process the traffic, so that means there will not be any kind of intrusion within the environment. Okay, but in SD-WAN will use the features of a firewall within the routers. Okay, uh, so the routers, as in we can use VH devices or CH routers. So it's Viptela edge routers or Cisco edge routers. Within those routers, will um, will add the features of a firewall, okay, so that it can provide a security to a traffic which is moving from branches to a data center, okay. And okay, and the other concept which I have already told you, that the MPLS is working will be working as a primary link in the internet as a backup in enterprise network, and in SD-WAN it will monitor the transport links, so that to to monitor the performance of an application on the transport links, and if any of the transport link is not performing better, it will switch the application traffic to another link. Okay, so the other challenge which the enterprise network have a deployment. So to deploy a single branch, it will take approximately 1 to 2 days. So assigning a branch is kind, we will set up switches. Okay, then we'll set up a routers. We'll configure the routers. We'll upgrade the iOS on the routers. Okay, so all these things, the whole process will take approximately 1 or 2 days to set up, or you can say 2 to 3 days to implement. Okay, so this deployment challenges can be overcome through a centralized management system in SD-WAN called vManage. Okay, and so the same vManage is used will be used as this vManage will be used as a single plane of glass to manage the complete network. So how the SD-WAN is solving the problem? So we have vManage in SD-WAN. So this vManage will be working as a centralized management system, okay, and so that it will monitor the complete uh, environment, the complete network. It can monitor the policies, it can monitor the routers, VH, CH, it will monitor the iOS, okay, it will monitor the configuration. So we can see everything within a network through a centralized management system. Okay. The other control device within the SD-WAN is a vSmart. So the vSmart will be acting as a centralized system which can do a routing adjustment. So it will monitor the WAN links to check the optimal path for an application and switch the application traffic from one transport link to another. If the internet link is not performing better, it will move the traffic to the MPLS. If MPLS is not performing better, it will move the traffic to SD-WAN. So the vSmart will push the policies so that the traffic can be moved from one transport link to another. Okay, so this is the introduction of the SD-WAN. So in my upcoming videos, I will explain you the different concepts, other concepts of the control plane, data plane, and the different controllers. What are the different controllers within the SD-WAN, and different routers in SD-WAN, and the function of the function of the controllers and how the connectivity, how the traffic will move within SD-WAN. Okay. Okay, thank you for watching this video. Hope you like this video. If you like this video, please do hit a like button on this video and subscribe to my channel for more videos like this. So, if you have any questions, please put it in the comment section. Okay, and I will try to answer the questions as soon as possible. Thank you for watching this video. Have a wonderful day. Bye.